In this presentation, I'm going to go over F distribution and p-value. What is F distribution? F distribution is a probability distribution that uses hypothesis testing for determining the equality of variances from normally distributed populations. The F distribution has the following properties. The density curve is not symmetric. The density curve is not bell-shaped. The density curve is skewed to the right. The total area under the curve is always 1. The F distribution comes with 2 different degrees of freedom. One is called numerator degrees of freedom, NDF, and the other degrees of freedom is called denominator degrees of freedom, DDF. This is how generally the F distribution curve looks like. And this is true when the numerator degrees of freedom is greater than 2. A common question is, where does F distribution curve peak? When the numerator degrees of freedom is between 0 and 2, the F distribution goes to infinity as F gets closer and closer to 0 from the right, from the positive side. When the NDF is equal to 2, F distribution curve begins at the point 0, 1, and it will be decreasing from there, skewed to the right. When the numerator degrees of freedom is greater than 2, the F distribution curve has a peak point at this formula. You'll see on the next example how to compute that. Find a value f where F distribution curve peak when the numerator degrees of freedom is 5 and the denominator degrees of freedom is 8. So all we need to do, plug in these values into the equation and simplify. So the peak value of the F distribution curve with this given information happens at the point 0.48. Now let's look at probability with F distribution using TI. The TI command that we will be using is called FCDF, and you can find that by going to second vars, arrow down until you find FCDF. This chart will tell us how the command is going to look like in different situations. The FCDF takes 4 entries: lower, upper, numerator degrees of freedom, and denominator degrees of freedom. You'll see these in the next few examples. We want to find probability that F is greater than 5.75 with numerator degrees of freedom 4, denominator degrees of freedom 10, and we want to round our answer to 3 decimal places. So we're going to draw, we're going to shade and label accordingly. Now we're going to use the TI command, FCDF. Lower would be 5.75, upper would be E99, 4 and 10 for the numerator and denominator degrees of freedom, respectively. And that probability is 0.011. Now let's look at this example. Find probability that f is less than 0.125 with numerator degrees of freedom 3 and denominator degrees of freedom 12. Again, we're going to round to 3 decimal places. We're going to draw, we're going to label, we're going to shade accordingly. Now we're going to use TI command FCDF. Lower would be 0, upper would be 0.125, with a 3 and 12 for the numerator and denominator degrees of freedom. And that area is 0.056, and the area for us will be the probability. In this example, we're going to find probability that f is less than 0.5 or f is greater than 6.5 with both numerator degrees of freedom 8 and denominator degrees of freedom 8. Again, we're going to round to 3 decimal places. We're going to start by drawing, labeling, and shading. Now, since we want the tail areas, we're going to subtract the area that is in between and subtract that from total probability 1. So that would be 1 minus FCDF. Lower would be 0.5. Upper would be 6.5. Numerator degrees of freedom 8. Denominator degrees of freedom 8. And that, the answer is 0.181. Now, what is p-value? Assuming the null hypothesis is valid, p-value is the probability that observed data supports the null hypothesis. A low p-value provides evidence against the null hypothesis, often resulting in rejecting the null hypothesis HO. And a high p-value suggests the observed data are consistent with the null hypothesis. Therefore, we fail to reject the null hypothesis. Now, p-value suggests the smallest level of significance alpha for which HO would be rejected and H1 would be supported. Now let's look at p-value and the computed test statistic F. Now this is our F distribution curve. That's our CTS F. We can find the right area. We can find the left area. The left area will be the p-value if it's a left tail test. And for the right tail test, the right area will be the p-value. In the case of two-tail test, we find the area on each side, and then p-value will be twice the smaller area. Now we're going to go over some examples to see how this works. And we can do those things by basically using the FCDF command on a TI calculator. For the right tail test, the lower value will be CTS and the upper value will be E99. For a left tail test, the lower value will be 0 and the upper value will be the CTS. And for a two-tailed test, as we mentioned, find the area on both sides and multiply the smaller area by 2. In this example, we want to find corresponding p-value for a right-tailed test with CTS F of 4.25, numerator degrees of freedom 5, denominator degrees of freedom 9, and we're going to round to 3 decimal places. Again, we're going to draw, we're going to label, we're going to shade. This is a right-tailed test, so we're shading on the right. So the p-value will be that area. Using the TI command FCDF, lower would be 4.25, upper E9, E9, 5 for the numerator degrees of freedom, and 9 for the denominator degrees of freedom. And that answer is 0.029. So that would be the corresponding p-value. Now let's find the corresponding p-value for a left-tailed test with CTS F of 0.275, numerator degrees of freedom 8, and denominator degrees of freedom 10, and once again we round to 3 decimal places. We're going to draw, label, and shade accordingly. This is a left-tailed test, so we're going to shade to the left. P-value will be that left area. Using the TI command, FCDF, lower would be 0, upper would be 0.275, numerator degrees of freedom 8, denominator degrees of freedom 10. And that answer after rounding would be 0.040. That would be the corresponding p-value. Now in this example, the CTSF is 5.875, numerator degrees of freedom 9, denominator degrees of freedom also 9, and we want to round the answer in 3 decimal places. We're going to draw and clearly label. We're going to find the right area. We're going to find the left area. Since this is a two-tailed test, the p-value will be twice of the smaller area. In this case, will be twice of 0.007, so the corresponding p-value will be 0.014. Another example for a two-tailed test with CTS F of 0.5, numerator degrees of freedom 8, and denominator degrees of freedom 12. We're going to draw the curve and clearly label. We're going to find the area on the right of the CTS and the area on the left of the CTS. And since this is a two-tailed test, p-value will be twice of the smaller area. In this case, will be twice of 0.166. So the corresponding p-value is 0.332. I hope this presentation helps you understand the F distribution, how to find probability with F distribution, and how to find the corresponding p-value when the CTS is F.